So let's look at the control flow. So this is again back to C. And so we have main and we have some numbers, some variables for results. And you see that here we have the power function being called and we are passing x and p. So this is going to take the flow of the code to the function. And of course, this logic is going to execute. And then when we get to the return, we're gonna come back to this and basically take this result that we have, or this res that we have, and store it in result. So that is what's going to happen. And then after that, the flow gonna continue here. So we get to this line, and again, we have the function. So that means, again, the flow goes to the function, runs the logic, have some result or return value, and it's gonna return, but this time it's gonna come to this line. So it's gonna save that into result 1. And that's basically finished the execution. So the question here is that how does the compiler or the processor knows that when you are calling this function from two different places, both times you are going to the function, but when you are returning to different locations. So how does the processor knows that it has to go back to this location or that location? So what happened behind the scene is that when you actually call the function, we're gonna save this return address. And after executing the function, you're gonna come back based on that return address. So basically that's the only way that you know where to come back. So again, when we have the second time that we are calling this function, we are saving the return address. And after the function is executed and is done, we are going back to that return address. So the way to do it in MIPS or assembly in general, these are the steps that we take. And this is basically following the same thing that we are talking about in C, but it's more manual. So we have to do a step by step. So the first thing that we do is to put the arguments in A0 to A3. So if you have one argument, you just put it in A0. If you have two, you're using A0 and A1. So that's the first step. You put your arguments in the A registers. The second step is that you're using the JAL instruction. So JAL is actually standing for jump and link. So this does few things. And basically what it does, which is explained here, it's gonna do, well, two things. The first step, it's gonna save the return address to register 31 or register RA. So that's the first thing it's gonna do. It's gonna save the return address. And then it's gonna go to the label that you specify. So you do, for example, JAL, and then you put your label like my func. And then it's gonna basically save that return address in the register RA. So that's a special register reserved for this purpose. And then it's gonna go to that label. And the last thing, your function gonna execute and you are going to basically come back from that function, and that's responsibility of the function. So you shouldn't worry about that if you are calling the function. And what you should worry about though is to get the result that you expect from that function. So after the function is executed, you're gonna come back to your basically wherever you were executing before. So whenever the line next, basically the line after jump and link, and at that point you have the return value stored in V0. Or if you have two, it's gonna be V0 and V1. So that's basically the three steps that you should take if you are calling a function. So again, here we have two roles that you should not confuse. We have somebody who's calling the function, and we have the function itself. So this is from the perspective of calling the function. So arguments go to the A registers. You use JAL to basically go to the function while saving the return address. And then the next line of that, you can take your values from V0. So what is the return address? So if you notice on the previous slide, after executing this line of code, so after we return from that, we actually continue execution to the next line. So the return address is always next line from the current line of code. So when you are coming back, you don't want to go to the same line again because you already execute that. So it always should go to the next line. So the return address is going to be basically the program counter that is the current line of code. And you can see that on MIPS on the side, on the registers, you can see that number, plus 4. So why 4 again? Because if you remember, when we are talking about the memory, we said that each instruction is actually 4 bytes. And the address that you are using, there are increments of 4. So that's how the instructions are done. So if you have multiple function calls, it's going to get a bit more confusing and complicated because one function can override the return address from the previous function, and basically you're going to lose when you want to go back to the original location. So that means that if you have multiple function calls, the function should make sure to save this return address and restore it. And we're going to see examples of that. So here is kind of the summary of what we talked about. So you have the JAL or jump and link, and then you're giving the label. So that's your instruction. So what happens when you do that? You're getting the return address stored into RA. So that's basically what is stored in RA. It's going to be return address, and then the current line of execution is going to go to label. And we could basically break this one to a step, to 2 instruction, and do this manually. So how do we come back from the function? So if you are writing the function, we have this register that is called JR or jump register. So in general, if you had just J, that's the jump. So that's the unconditional jump. So if you had just a J and a label, it would jump to the address of that label. So the difference that JR is doing is that instead of getting a label, it's going to get a register that has that address stored in it. So you could achieve the same thing using JR or J, basically. J is going to be hard-coded because you have to give a label to it, but JR is more dynamic because you can save that address and modify it in a register. So how do we use this to return from a function? We basically do JR, so jump to the register, and then we give the return address. So this should be the last line of the code in your function. And basically that's allow you to go back to the line after JLL.